So welcome to another today's lesson, guys. And the previous one, like how you have reviewed the lesson, we talked about lipids, the fatty acids, the type of fatty acids, the condensation, how lipids are formed, and then we talked about the phospholipids and why you need to form a phospholipid. The functions of phospholipids, and we agreed that they are used or they form cell membranes. And so today we are going to talk about the functions of lipids in general. And we saw that from your research or from what you have given me, which was really good, you saw that we can classify the functions of lipids into different categories. Okay? And the functions can be structural, where lipids are used in formation of structures, but the functions can be physiological, where lipids are involved in the physiology of your body, and finally other functions, commercial uses, stuffs like that. Okay, so those are the functions. So if we begin with the structure functions, they are components of the plasma membrane, and you gave this. Okay, and this is, you know that plasma membrane is a double layer. It's a double layer of phospholipids. So you have a phospholipid, and these phospholipids, they are lipids. Okay, and then you have another layer. So it's a double layer of phospholipids, and so meaning without these lipids, then you cannot form the phospholipids. Okay, and so you cannot have the membranes. So this is really some important achievement as far as lipids are concerned. So for this, we shall give lipids a goal. Maybe when you are comparing lipids and carbohydrates, which one is more important, which one is more useful, like our kiddish discussions. Remember when we were young? This is just away from the lesson. We grew up watching movies and would compare Rainbow with Schwarzenegger. Which one is better? You compare Chuck Norris with Mangere. Which one is better and who can beat the other? But that were some kiddish, some fun. Okay? As far as childhood is concerned. So you also hear, and you are comparing lipids and maybe carbohydrates, you can give lipids a goal here. Okay? So they are the components of plasma membrane. Then another one, yes, they do form the subcutaneous fat in the dermis of the skin. And here, this subcutaneous fat, it's a layer under the skin, okay, that is, you deposit fats there, enough of them, okay, in the adipocytes, so that one, you temporarily store fats there, but you want a function of fats there, it is, you insulate the body, okay, against heat loss, because you know that fats are poor heat conductors. So you insulate the body. That's why on a cold day, too cold, you find this big woman, this fat zone, in her armrest, busy swinging her arms, as if she's not feeling anything, as if everything is okay. Okay? Why? Because she has deposited enough fats, okay? And the fats are able to insulate her body against heat loss. And yeah, you gave it. Anita, you gave it. That was good. Then components of the wax cuticle. And the wax cuticle forms that transparent layer that covers the upper epidermis in most plants, and on rare occasions the lower epidermis in some plants. And so this wax cuticle prevents excessive water loss. You know, fats, they are impermeable to water. Okay? So you prevent excessive water loss. Okay? So that you conserve some water within this plant leaf. Even in insect. Yes, the insect skeleton, I was trying to challenge you that it's made up of cuticle, chitin. Okay? Or you can say chitin depending on your kindergarten. And chitin is a polysaccharide, we saw that. But within this layer, within these layers, these chitin layers, you will deposit there the wax. And this wax, you know, it's a fat, it's a lipid. And the wax is impermeable to water. Okay? And the chitin for it, the chitin for it, if it was just layers of chitin, it will just freely allow water to penetrate through, just like cellulose. But these insects, they are terrestrial, where they take decades to drink water. Can you imagine? Have you ever seen a cockroach drinking water? Have you ever seen a housefly drinking water? What? Which other insect? Have you ever seen an insect drinking water that be like, man, I think I'm thirsty. Let me have a glass of water. No. So they are terrestrial, and with the terrestrial environment, the challenge is water. So you must find ways of conserving the water. And so these ones, they do conserve their water by having that exoskeleton that is full of wax. And wax cuts off the water supply. That the water loss. That the only water that is lost from their body is through spiracles. When it has opened a spiracle to take in oxygen and take out carbon dioxide, then water evaporates in the process. So this is really good. This is really a good function of lipids. Then they form a component of the myelin sheath. Nobody talked about this. So if this is your nerve fiber, and this is the axon or the axon, and these are the terminal dendrites, dendron and then dendrites, and then you have the cell body here, and then dendron and then dendrites. You will have the myelin sheath. Okay? You have the fat deposits along the axon, and these fat deposits are secreted by a special glial cell called the Schwann cell. Okay? Now this Schwann cell, it is the one that secretes these fats. Okay? And the fats, they do surround the axon. Now these axons, these myelin sheath, they are good as far as impulse transmission is concerned, that they do improve on the speed of impulse transmission. How? By insulating ion exchange at these points and allow ion exchange at nodes of Ranvier. These nodes, they are called nodes of Ranvier. That's why you have ion exchange. And so these are the ends, these are the parts of the axon that will be depolarized. Okay? And so the impulse will be transmitted along these nodes of Ranvier. Okay? And so it will be transported in form of a jump, in form of a leap. It will be leaping from here, and then here, and then here, and then here. And we call this one the saltatory mode of impulse transmission. Now this salutatory mode of impulse transmission is far fast as compared to when the neuron, the axon, was non-myelinated. So this one is going to be transported faster than when it was non-myelinated. Okay? Yes. So this is one of the most vital functions of fats, that your body must have fats. Not so? Yes, in case of any queries, feel free to reach the inbox. If it's immediate, then it's okay, you can unmute and ask that question. Then these fats, they do protect delicate organs such as the heart. Imagine you are running and you accidentally knock yourself and fall down in a big shock. All that force, it will be distributed to the internal organs. And so the internal organs, they'll also be, they'll move up and back to their normal position at a high pressure. So now if you don't have fats, imagine the high jumpers, people who do high jump, people who play soccer, people who are active. You jump up and you run. So the same pressure is distributed onto the internal organs. So now, the good news is, these internal organs, they are going to be surrounded by a layer of fats. Okay? Surrounded by a layer of fats. That's why when you slaughter your chicken, you slaughter your goat, you find fats. If the chicken is fatty, then these organs will be having many fats. Now these fats, they do absorb that shock that would reach the organ to damage it. So they do absorb that shock. Okay? And your organ is safe, your heart is safe, your kidneys are safe. Okay? Your lungs are safe. But without these fats, it's like one day you should sit in a car that doesn't have shock absorbers. You will really appreciate this. Okay? You look for a car, some old model, but with no shock absorbers. Where the shock absorbers are loose or they are, you will appreciate this. Whichever knock, whichever car hole, whichever car pothole you pass through, however small it may be, whichever hump you have, you become the shock absorber, you yourself. You absorb the whole shock. Okay? But because these new cars, the cars maybe you have, I don't know. But because those cars you have, they have shock absorbers, then when you pass through such, then the car just, and then it gains its normal position. Okay? Oh, it's okay. Because the car has shock absorbers, then it will just, and then it gains its normal position. So basically that's good. That's how good fats are. Then they do quote fat. Yeah, Anita gave this. That was good. Because I want you to observe a cow, okay, in when it has been hit by the rain, or a hen, okay, also hit by rain. As this rain, or even the practical you did, by the way, the practical you did in senior 4, okay, it was, you used feathers, where you would pour water on the feathers and water just slips. Okay, but also these cows, sheep, goats. The cow stays in a rain, and it takes hard for the rainwater to reach its skin. It's hard for the rainwater to reach its skin. Not so? Why? Because these fur, they do have a layer of lipids, and this layer of lipids, it is the one that is impermeable to water, so that the moment this organism, the moment this water falls on the fur, the water just slips off, just slips off, just slips off. Even this bird, the moment water falls on the feather, water just slips off. Okay, and the interior, the internal of the organism remains warm. Okay, if it's a bird, then the feathers are not weighted. Okay, so that it remains, it doesn't gain that too much weight to easily fly, so that it can continue with its flight. So it is, these lipids are really good. They are really good. They are really good. Not so? So in case you have a query, please, you can drop it. Then there are components of the adipose tissue for storage, and you do the same. You insulate the skin against heat.
Teacher,
Yes,
teacher,
yes.
cholesterol is a steroid, no? So
Cholesterol is,
a steroid.
it is a steroid, and it's a lipid also.
What?
It is a lipid also.
How?
We studied steroids. Those with
No,
yes. Go ahead.
it's a steroid and the same time a lipid,
Steroids are lipids.
but ring form.
Yeah, in a ring form.
Another question. Another question.
Yes.
What's the function of cholesterol?
Function of cholesterol.
Yes,
We studied.
because
Yes, you can.
I see it in the plasma membrane.
Yes, that's good.
Yeah, yeah, but I I I don't know the function. I've not yet read this yet, but I'm not. I don't know.
Okay. So cholesterol, one, it is a component of the plasma membrane. Okay? Of a plasma membrane. Now, whereby it maintains the membrane fluidity. Whereby at high temperature, the cholesterol maintains the membrane. Even at low temperatures, still the cholesterol maintains the fluidity of the membrane. We discussed this as far as cell membrane is concerned. You
I've
can
recalled.
you can
Teacher,
watch it.
no, teacher, I've recalled. But when you told me when you were speaking about steroids,
Yes.
in my head, the most of the steroids you were speaking of, testosterone, progesterone, in my stuff started reading about hormones, and I was wondering how can cholesterol be a hormone? That's why I was asking
Okay.
for the function.
Okay. Even wax is also a steroid. Okay. The wax of ours, it is a steroid. Even the cholesterol is all. No. Wax is not a steroid. It is the fatty acid together with
Wax.
an alcohol. No, wax is not a steroid. But the cholesterol and the steroid hormones, they are all steroids. Okay? Yes, but depending on the groups that are attached on that ring, it will determine which type of steroid and the function of that steroid. Not so?
Thank you.
Yeah, yeah, you're welcome. So that's why it's not good for ladies to keep taking these steroid hormones, the synthetic steroids. It's not good. You can read about it, you can Google synthetic steroids. Okay?
Taking them how?
Okay, taking them how? Have you ever heard of family planning?
Yeah,
Have you ever used one?
nonsense.
No, why nothing? Is it funny?
At my age,
Does it have a specific age? Anyway, it's okay, it's okay. So those are synthetic steroids. They are the ones which are used in family planning. And when you use excess of them, when you use excess, then they have their own secondary complications. So it's not good for a lady to always use family planning methods, especially these the contraceptives, the pills, the injections, and the IUDs. Those ones, not not good. Okay, it's good. It's one of, but not to overuse them. So physiological functions.
teacher, the reason is it because it causes fibroids?
Yeah, one of them. They can cause fibroids. They can cause if in excess they are converted to cholesterol, and cholesterol will lead to issues in those cardiovascular diseases and others. Others. I don't want to go deep into that, but it's a reading assignment. Go and read about the synthetic steroids. Not so. So physiology, the physiological functions. Now the physiological functions, these ones, how lipids are used by the body. Okay? Apart from formation of structures, how else are these lipids used by our bodies? So number one, they do provide energy when they are oxidized. Yes, on times of, should I say starvation? No, not yet starvation. You haven't reached there. But when the carbohydrates are depleted from your body, then the body resorts to metabolism of lipids. Okay? Whereby you oxidize the lipids to produce the energy and water. Okay? And actually, these lipids do produce more energy than what carbohydrates produce. If you consider a given mass, maybe 1 gram of lipids and 1 gram of carbohydrate, okay? And you heat them, for instance, the 1 gram of lipids is going to produce too much energy, or relatively higher energy, than what is going to be produced by 1 gram of carbohydrates. You can try this at home. How are you going to burn? So, because of this fact, then lipids yield much more energy than what carbohydrates do. But however, the body prefers metabolism of carbohydrates than lipids. Can you find out why? The body prefers to respire carbohydrates to lipids. That the lipids must first get depleted, and then the body resorts to the carbohydrates must first get depleted, and then the body resorts to lipids. Number two, like we've said, they are solvent for fat soluble vitamins, ADEC. Okay? How does your body store these vitamins, how does these vitamins cross? Since they are fat soluble, then they can easily cross the plasma membrane, okay? Because they will dissolve in the lipids and they cross with ease by just simple diffusion. And then you get the vitamins and you carry out what you need the vitamins for, okay? Then they are good source of metabolic water. This word is key. Don't just say good source of water to desert animals. They are good source of metabolic water. If you are keen enough, if you know a camel, okay? If you know a camel, the camel has 2 humps. Is it humps? The Waganda say 2 bangles. So it has 2 humps. It has this and someone here. Okay? Now, what are these 2 humps? And of which one is large, too big than the other. Now, the 2 humps, they do store too much fats in the 2 humps, in these humps. And so that, remember these organisms, it's hard to get water because they are the deserts. They are desert animals. They live in deserts. You walk kilometers and kilometers to find an oasis, to find a source of water in the desert. So therefore, these organisms store a lot of fats, and because of a high carbon, high hydrogen to carbon ratio as to compared to carbon oxygen ratio, okay? They have very many carbon hydrogen bonds, okay, than their fellow carbohydrates. Then when they are metabolized, when they are oxidized, they will produce a lot of water, okay, which is going to be used by this body by this organism in other physiological processes, okay? The young birds and reptiles, while still in the shell, same thing. You oxidize lipids, you produce water, and you use this water, okay, in other body metabolism. And so this is really good. This is really good. These organisms have managed sort of that. Then they regulate temperature when oxidized. Sorry for that. So when they oxidize it, or when they are broken down, like we say, they produce too much energy. So the energy can be in form of heat. Okay? So when oxidized, they produce too much heat, which the heat is absorbed by the body tissues. Okay? To keep them warm. Now, these 2 points are different. The point insulation, okay? This one is structure, it is physical. It is a structure. But the point producing a lot of heat when oxidized, it is physiological. That is physiology. Not so? That is physiology. Because it involves a physiological process which is respiration. So they must be broken down or oxidized, and then the heat that is produced in the process, it is the one that is going to maintain the tissues warm. So note, okay, let's first finish them. Okay, these are others. Now, I can decide to set a question, and the question is just for that. Outline No, for you can't outline. Briefly, uh-huh, explain mhm, the physiological functions of lipids in the body. So any point you give, and I give 8 marks, you can check UNEB 2019, paper 2, I think, if you can have a question bank, or if you can find that paper. This question is there, and I give 8 marks. So any answer you give that is not physiological, we cross. Okay? Yes. If you give structure, you lose marks. But the answer should be specific with physiology. Not so? And maybe we shall have one question session and we answer these questions. And we see how we can answer, how we can attempt questions. Because it is also good. On top of knowing the science, also need to have some expertise as far as attempting questions is concerned. Because that's how we shall be examined. Okay? Yes. Is having some pocket science but packaging the science into a way that is into science that can be presented. It's key. Then other functions, they provide scent in plants which attract pollinators. The wax is used by bees to construct honeycombs. Yeah, you said this. And then wax from bees is used in manufacture of candles. Now, properties of lipids that make them good storage compounds. Why do why do our bodies prefer to store these lipids? Why would fish, for instance, prefer to store lipids as their form of energy than storing carbohydrates, for instance, than storing proteins? Actually, our bodies don't store protein. So which properties of lipids do they possess? Well, I can also decide to set such a question, and I be like hmm, relate the properties of lipids to their functions. To their functions. Now, this question is good also, whereby it requires you to dissect this slide and the previous slides and talk about which properties do lipids possess that make them good for their functions that they have, that make them suitable to perform their functions that they do. Or in other words, I can say adaptations, if I want to be direct. Okay? Adaptations of lipids to their functions. So the questions are the same. And please, this part is good because it is liked so much. If you can relate the properties, then it means you know what lipids are to functions. Then it means you know functions. Okay? Yes. So this question is really good and high chance. I can give it 70% chance of it appearing in your first question, in your first exam that you will do when you go back to school or when you reach school. 70% chance that this question is going to appear. Okay? That is if you study chemicals of life and you reach lipids. I give it 70% chance that this question is going to appear. And if all of you go to different schools, When you come back, you can even testify this. At least one of you would have to testify that this question came. So please take note. Take note. They are compact. They are highly compact. Okay? Hence they take up little space for storage. Okay? Yes, because for you to store, then you must have where to store. You must have a store. So imagine if they were just parallel. How much storage space would you require? But because of highly compact, they are highly compact, then they take up little space for storage. Then these lipids, they are insoluble in water. Okay? They are insoluble in water. Hence, number one, they don't affect the osmotic pressure. Okay? Affect the osmotic pressure of cells. Number two, they cannot easily diffuse out of the cells. Otherwise, imagine if you have your adipocyte and you have deposits of lipids. So how will this cell easily manage to stay in such a cell, okay, without escaping to the outside environment? So if these lipids were soluble, then they would easily diffuse out of these adipocytes, these cells, okay? And if they diffuse out, then I don't know where they would go. I don't know what would happen. So because they are insoluble, then they don't affect the osmosis of the cell, the osmotic pressure of the cells where they are stored, and two, they cannot easily diffuse out from cells where they are stored from. Then they are light, hence keeping organisms light, especially those ones which require buoyancy. You know, the blubber, is it double B? I think it is something of this kind. Blubber. So now these aquatic organisms, instead of storing starch, instead of storing carbohydrates in their bodies, yes, they are diving mammals, not mammals, or they are diving organisms. They do stay inside the waters, and this process requires a lot of energy, that you have to store enough food. But now, you cannot store starch, you cannot store carbohydrates, you cannot store glycogen. Why? Because these are carbohydrates, so they have relatively high molecular masses. You see, carbohydrate is C6, this is glucose H12 and O6. So how can you compare this with just C and then just O something, the fatty acid? So for carbohydrates, they will be heavier than the fats. The fats are light. Okay? And so the organism that needs to dive, then you will have high deposits of fats, which will contribute relatively negligible or negligibly, whatever the case, to your height, sorry, to your weight, and so you maintain that buoyancy, ability to float on water. But you also produce energy whenever it's needed because you have enough food. High calorific value compared to their fellow carbohydrates. Yes, they yield a lot of energy when oxidized. High hydrogen to oxygen content. If you compare the ratio of hydrogen to oxygen in lipids and the ratio of hydrogen to oxygen in carbohydrates, it is high in lipids. And so lipids yield a lot of metabolic water when oxidized. and so it is preferred by the desert animals, okay, that really need energy, that really need water, okay. Their water is a challenge, and so these ones prefer to store lipids, where when oxidized, they will yield a lot of water, which can be used by their body. So it's a secondary function. Not so? Yes, and the others. You can make some research. You can make some research. Then how do we test for lipids? Number one, we have the translucent spot mark. This is ethanol first, or the immersion test, where you get 1 centimeter of the food that contains a lipid. Then you add 5 drops of ethanol, and then you follow it by the 3 drops of distilled water and shake. Okay? You get your ethanol, so that you get your food that contains lipids. You add 5 drops of ethanol, and then you add 3 drops of distilled water. If a creamy emulsion is produced, then you know that lipids are present. But if a creamy emulsion is not produced, like cream, this time, okay, I will say that. You know cream, you know when the lipid, it will just be normal, then it will turn into cream. Maybe I'll get for you some pics and I show you that creamy emulsion. So if you produce that creamy emulsion, then you know that your food contains what? Lipids. But if the creamy emulsion is not produced, then the lipids are absent. Then there is one which is easy, the translucent spot test. And I also show you this, but I'm sure all of you, you've ever seen this somewhere. Okay? Whereby with this, I'm sure all of you have ever bought chapatis. Let me use Rolex because it is the one that is common to both girls and boys. Yes, you've ever bought Rolex, and then they put the Rolex in the paper bag. Something, I cannot sketch the paper bag. Something of this kind. So you hold here. So they put the Rolex in the paper bag. That when you come and remove your Rolex, you try to look at the paper bag, okay? It will have some spots, okay? The translucent spots. And what are these spots? That's where oil poured. Oil from the chapati, oil from the Rolex. When it touches here, then you form some spots. I'm going to show you the pics of the translucent spots, okay, from Google. So if that is the test that you are going to do, so what you do is you get your filter paper, okay, and then on the filter paper you get your food solution or your food sample. If it is a solid, same. If it's a solution, you just add, if it's a solution, you just add drops of the food on that filter paper. If it is a solid sample, then you just rub that solid food on the filter paper, and then you just wait. That after some few minutes, you will see some translucent spot formed at that point where you dropped the food solution, or at that point where you rubbed the food. And if you get that, boom, then lipids are present. No other food can form a translucent spot. That's why when you can wrap your cassava, I mean boiled cassava, not fried one, in a paper, and the paper remains dry. But you wrap there mandazis, samosas, chapatis, stuff like that, the paper will end up becoming wet, translucent spot, to become translucent. So that is a test for lipids. And we shall do all this as far as practical work is concerned. Okay? Yes, you have to do that. Then finally the Sudan 3 test. Okay? Now this one, it's a reagent. Okay? And I'll also show you. So this is a reagent that contains ethanol. It is more of this by the. It contains ethanol together with a dye. Okay? Some dye. And it is the dye that will give you that brick red PPT. No, that brick red emulsion, not PPT. So to 1 centimeter of the lipid in a test tube, you add 3 drops of Sudan 3. And like I told you, Sudan 3 contains ethanol. So the ethanol will do the same. Here we just add drops of dilute distilled water, and then we see a creamy emulsion in the whole solution. But here, because there is that dye, then it is the dye that will give the color of the mixture. So you add Sudan 3 and then shake and leave it to stand for 2 minutes. That after 2 minutes, the oil layer which settles on top is red in color, and the water beneath under it remains colorless, which indicates the presence of lipids. So, simple. So because this Sudan 3 it has ethanol, the ethanol break down the fat, okay, into I think triglycerides, and then this oil layer, which is dyed, it has some color. The lipid now, it will dissolve in the oil layer, this one, okay, and then it is red, so it will form that red emulsion on top, and then the water down, because lipids, if you use the lipids together with water, they will dissolve in the oil layer and the lipids down will remain. So basically that's the Sudan 3. Maybe let's have a look at these tests. The emulsion test, the translucent spot test, and the Sudan 3 in Google Pics. Let's go and check the Google Pics together. So this is the emulsion test. Okay? So this is the creamy emulsion that I was talking about. Okay? Yeah, courtesy of Google. So yeah, this is the creamy emulsion that I was talking about. Now the lipid, it settles up. But if you don't see this, maybe the turbid solution remains turbid, or the colorless solution remains colorless, but obviously a lipid solution cannot be colorless. Okay? Then it means your solution does not contain any lipids. So this is what I was talking about. Then let's talk about the translucent spot test. For basically this is what I was talking about. So here they were testing for lipids in different substances. Here this is coconut, this is corn, olive oil, peanut, this is linseed, cod, whatever it is. But the issue is the taste. So on here where they dropped the lipid, you can see, this one is actually good. So you can have a look. Here they dropped cooking oil, and here it's water. So you can have a look. You can check the difference. So lipids do form a translucent spot. Okay? You can have a look on the paper. So no other food substance can form this. Okay? So if you form this, then it shows that the food contains lipids. And this spot, by the way, it's permanent. Now you can see that for water, where water drop is when you leave this filter paper to dry, it will become normal again. But this one where the lipid has, it will stay like this. So the spot is permanent. Okay? So let's have a look at Sudan 3. So you can have a look. This is the oil layer that we've been talking about. Okay? It forms that red brick layer for lipids, if lipids are present. Now because lipids are less dense, okay, than water, and because lipids dissolve in the oil, like I told you, the Sudan 3 is ethanol together with oil mixed with a dye. Okay, so the oil layer is going to settle on top. This is good. The oil layer is going to settle on top. Okay, and then at the bottom you just form a colorless or a turbid solution, which is purely water. So basically it is as simple as that. So courtesy of Google Pictures.